Hello Algebra 2. This video lesson from chapter 6.6 is one where I'm going to walk you through a couple of different examples using the rational zero theorem. And I'm going to start with the guide that I gave you. This printed guide was handed out in class. If you weren't in class, you can also download it from my website. It starts with this problem, and I do work through that one in the printed guide, but I'll talk it through first as my first example. If I want to find all the zeros, in other words, all of the roots, in other words, all of the x-intercepts of this polynomial, first I can find all of the possibles. And that's what the rational zero theorem does for you. It says that the possible answers, the possible solutions, are going to be a ratio that has all of the factors of the constant term, in other words, all of the different factors of 24 on the top of a fraction in the numerator, and all of the factors of the lead coefficient, in this case 1, in the bottom. Okay, so that possible list, well, the factors of 24 are here. And keep in mind that each of these could be positive or negative. The possible factors of 1, and in this case it's particularly easy when the lead coefficient is 1, are just plus and minus 1. Okay, well, when you're dividing by plus or minus 1, well, keep in mind the plus and minus doesn't really add anything to the story because we already had both positives and negatives up here, so we don't really need to say plus and minus down here. And likewise, dividing by 1 doesn't add anything. So really, in the nice case where your only denominator is plus and minus 1, you can just deal with the numerator. So those are my options. What are they? 3, 6, 8 different options times 2 because plus or minus, so really 16 different options. And you test each of those out using synthetic division. My recommendation is that you start with the easiest. 1 is always going to be a possible zero of any polynomial because it is a factor of any number. Okay, so I run 1 through using synthetic division. Bring down the 1, and you'll find as you run 1 through that it leaves you with a remainder of 0, which means that it did work, and 1 is one of the actual zeros, one of the actual x-intercepts or roots of the polynomial. Once you've found one that works, keep going, try another. So you might try -1 next, that's what I would do. If you do, you'll find that it doesn't work. I haven't worked that out in the guide, and I'm not going to work that through in this video. I'm going to go ahead to 2. So I bring the 1 down. Notice that the second time through, this being the first time through where I used 1, the second time through I'm working against the information that came out of the first time through. I'm using everything that came at the bottom of that process, 1, 5, -2, and -24. I'm not using the original coefficients up here. All right, so I bring the 1 down and I try 2 against this set of 4 numbers, and once again I get a remainder of 0, which means 2 works as well. So therefore, both 1 and 2 are factors, are roots or zeros of the polynomial. And what I'm left with here, 1, 7, and 12. At this stage, I might want to switch gears. At any point along the way, you can always factor, and that's in fact why we taught you factoring before we teach you this process with the rational zero theorem. You can always try factoring if you want. So I could have done that back here. Keep in mind, that would have been my constant, that would have been my x1, my x2, my x3. So I would have had an x cubed or cubic polynomial with 4 terms, and I could have tried factoring that. Here, if that's my constant, that's my x term, and that's my x squared term, I've got x squared plus 7x plus 12. I've got the choice. Do I want to try to factor this polynomial at this stage, or do I want to keep using synthetic division with the possibles that I had from my previous slide? Either way will work. I have, at this point, got it factored down to this point. I said that 1 is one of the zeros, so x minus 1 is one of the factors. I said that 2 worked, so x minus 2 is one of the factors. And the remaining factor is this trinomial, as I say, this quadratic that I've already talked about. Well, I'm going to go ahead and factor it. And when I factor it, I get x plus 3 times x plus 4. Remember, x plus 3 times x plus 4 is the same as this trinomial. So now I've got 4 factors. So the zeros are, well, I already talked about the 1 and the 2. If x plus 3 is equal to 0, then negative 3 is one of the zeros. If x plus 4 is equal to 0, then x is equal to negative 4, and therefore negative 4 is one of the zeros. That's it. Those are my 4 answers. And remember that the original question that I was given was of a polynomial degree 4, so I was expecting only 4 answers, so I'm done. Another way to know that I'm done, besides the fact that the number of zeros matches the degree of the original polynomial, is to realize that what I'd been working with here couldn't be factored any further. There's no point in trying the quadratic formula on any of these pieces. I'm not going to get any imaginary answers here. So these 4 are the complete set. Try this same process with another more challenging problem. In this case, the possible list are the factors of 16, which I've listed here, over the factors of 2. Now I've got additional options here because I could be dividing the top by 1, but I could also be dividing the top by 2, or negative 2 for that matter. Okay, well, separating this set into this list into 2 sets, the ones divided by 1, plus or minus 1, and the ones divided by plus or minus 2, I pretty quickly realize that a lot of the ones that are divided by 2 are already represented up here. 2 over 2 is 1, 4 over 2 is 2, 8 over 2 is 4, and so on. So really, plus and minus 1/2 is the only thing that I've added to the list that had been divided by 1. That's the only other unique possible zero. So I move plus or minus 1/2 into my list. I get rid of the other ones that I don't need. And now I've got 6 possibles times 2 because of the plus and minus. And I start, again, same place. I try 1. And notice once again, I've pulled down these lead terms here. But this time I had to put in 2 placeholder zeros because the polynomial I had been given jumped from exponent 4 to exponent 1. So I have a 0 for x to the 3rd and a 0 for x squared. Now I run 1 through, and you'll find you end up with a remainder. So 1 is not one of the actual zeros. I try negative 1, and I run that through. Again, I get a remainder. So now I'm going to try positive 2. I run it through. I do get a remainder of 0. Okay, so that means 2 is one of my solutions, is one of my zeros. And like I said in the previous example, keep going at this point. So you're going to try negative 2. But you're going to, I've already crossed off plus and minus 1. They didn't work. I'm going to try negative 2 as I say, and negative 2 does work. I end up with no remainder. So 2 and negative 2 are a pair of the answers I'm looking for. Now I'm going to try 4 and negative 4 and so on. If you go through this whole list, you're going to find that the 4s, positive and negative, the 8s, and the 16s don't work. And what I have left here at this point is a 4-term polynomial that's a constant, that's x first, x squared, x cubed. Okay, 2x squared plus, 2x cubed plus x squared plus 8x plus 4. And I can either try to factor that, or I can try plus or minus 1/2 going through it. It's kind of up to you. Do you want to factor this polynomial here, or do you want to try running positive 1/2 and negative 1/2 through? Either way will work. I'm going to try factoring it. The left side, I can factor x squared out. The right side, I can factor 4 out. And I'm left with x squared plus 4 times 2x plus 1. Okay, so if 2x plus 1 were equal to 0, oops. Sorry, my computer just crashed, so I had to relaunch. I was starting to say, if 2x plus 1 were equal to 0, then x would be equal to negative 1/2. If x squared plus 4 were equal to 0, then x squared would be equal to negative 4, or in other words, x would be equal to plus or minus 2i. So notice, negative 1/2 would have worked if I tried running negative 1/2 through these 4 terms. Either way is fine. I would have ended up coming out, if I'd run negative 1/2 through, I would have ended up with x squared plus 4, and then I would have had to figure out. I had 2 more imaginary answers left out of my list. And remember, I started with a degree 5 polynomial, so I should have 5 solutions, and sure enough, 1, 2, 3, and 4 and 5, because of the plus and minus, I've got all 5 of these solutions I was looking for. So the rational zero theorem did work, and I was able to find all of the solutions I was looking for. So now you've got one to try. With this degree 4 polynomial, use the skills that I just taught you in this video lesson and come back and tell me what all of the zeros, or in other words, all of the solutions are. And hit the pause button when you come back. I'm going to show you the solution. Okay, I'm going to assume that you did that. This is a long solution, so I'm going to walk you through some steps. The factors were the factors of negative 3 over the factors of 6. I mean, the possibles were. So those were your possibles, which reduced down to this list. And these are the 5 times 2, 10 possible solutions that you should have tried using synthetic division on your original polynomial with. Okay, so again, start with 1. 1 does work. And 1 worked, but you'll find that negative 1 doesn't work, neither of the 3's work, neither of the halves work, and neither of the 1/6 work. And in fact, plus 3/2 doesn't even work. So you were left now trying negative 3/2. Negative 3/2 does work. It does leave you with a remainder of 0. So 2 of my answers are 1 and negative 3/2. At this point, there are no other possibles left, no other possible zeros. And what I have here is this trinomial. 6x squared plus 0x plus 2, or simplified down, 6x squared plus 2. Well, if that were equal to 0, then 6x squared would be equal to, moving the 2 over, would be equal to negative 2. Divide by the 6, you've got x squared is equal to negative 2 over 6, or in other words, negative 1 over 3, which means x is equal to plus or minus the square root of that negative 2 over 6, or negative 1 over 3. Pull the negative out. I've got plus or minus I times the square root of 1/3, which you really ought to change because you shouldn't have a denominator under a radical sign. So plus or minus I times root 3 over 3 is the better answer, though I have been accepting this as an answer if you make it this far. So listing off all of the actual zeros. Remember, you are working with a degree 4, and there are 4 answers, plus and minus for imaginary numbers, as well as negative 3/2 and 1. If you put this into your graphing calculator, you will see these two x-intercepts. These, since they're imaginary, won't appear. And that's it. If you have any questions about this, don't hesitate to come into class with those.